Good afternoon, everyone. Today we will talk about Kafka. I will explain what Kafka is, what it is used for, show you how to install Kafka locally on your computer, and how to use it for data transmission between microservices. We will create two microservices that will communicate with each other through Kafka. These will be Spring Boot microservices. Kafka is a system for communication between microservices. It can be said that this is a distributed, asynchronous, horizontally scalable messaging system for communication between microservices. For example, we have two microservices that are part of a single application. How can they exchange information with each other? If this is a monolithic application, then they are part of one. It is one monolith, and they call each other through method calls or variables. In this case, these microservices must contain dependencies on each other. They cannot depend on each other directly, but at least one microservice must contain a dependency on another so that it can call it. Microservices can be standalone applications, and there can simply be direct information exchange between them, for example, through JSON files. But in this case, there is a significant risk of information loss during transmission. One of the solutions to this problem is the Kafka message broker. Kafka is an intermediary between two microservices for transmitting messages between them. Why is this method more reliable than regular direct transmission? Because, as I mentioned earlier, it is a distributed system which enhances fault tolerance. Fault tolerance is achieved by having multiple message brokers. That is, several servers that transmit information. This means that the information will be duplicated there, and it must be duplicated on 2 to 3 servers, or 4, or as many as needed. And the information will be copied as many times as needed. This way, if one server happens to go down, the information will be transmitted by another server. This ensures fault tolerance. I mentioned earlier that it is a horizontally scalable system. This means that when the load on the application increases, as the application grows and the load increases, you can simply scale up the computing power. This is a vertically scalable improvement. Horizontal scalability is simply achieved by adding more brokers. By increasing their number, the throughput between microservices is enhanced, thereby increasing the speed. Thus, we can flexibly adjust this number for the optimal operation of our system. For example, there could be such a system, such an application. We have a payment service that accepts some payment for something. It sends events or messages to the stream. When there is a payment processed, it sends this event to Kafka. We have services that read this message, such as notification service, inventory service, and shipping service. Our notification service sends the message. The inventory service and the service mean that the service sends us a message. For example, an email about a completed payment. This triggers the inventory service to calculate the remaining stock, and the shipping service initiates the delivery. It would be more accurate to draw arrows from these three services in the opposite direction, from here to there. Because Kafka does not send messages to those who read them. Kafka does not know how many users are reading it, or if they are reading it at all. These services need to be configured to listen to Kafka, and as soon as a new message appears here, they will immediately process it. This is all referred to as event-driven architecture. Event-driven architecture. This means that everything is based on events. An event in this microservice generates events through Kafka in these three microservices. We can add another microservice that will read events from Kafka, events of this type. And this will not affect this microservice or these three at all. This is the advantage of such architecture. The fact that we can simply add another microservice, and it will not affect all the other microservices in any way. The microservice that sends messages is called a producer, while the microservice that receives them is called a consumer. For example, in this diagram, we see one producer and 4 consumers. Of course, there can be a completely different number of them. There can be many producers writing a single message to Kafka. There can be one consumer. Here, in short, there can be anything. Now let's look at what Kafka consists of. A Kafka cluster is a dedicated space on the disk for Kafka used for message exchange. A Kafka cluster already contains Kafka brokers. Kafka brokers are software that runs on a computer locally or in the cloud, which is responsible for The transmission of information. Why can there be multiple of them? I already mentioned that several are launched for each resilience. If one server fails, the second or third will take over the work. The number of Kafka brokers is configured manually by the programmers. A Kafka broker can also be referred to as a Kafka server, the same thing, or a Kafka node. One of the brokers is a leader, while the others are followers. What does it mean to be a leader and a follower? The leader is the primary one that receives messages. The followers are those that simply copy it. They are just copies of it. And followers are needed only in case the leader fails. Then one of the followers becomes the leader and sends. While working on the main task, here we see a general diagram. There are 3 producers, for example, that send messages to the brokers, and there are 3 consumers that are grouped into a consumer group. But there is one more entity here. Zookeeper. Zookeeper is a system that coordinates all the work related to metadata and distributes the load. The broker determines which broker is currently the leader. However, Kafka is moving towards eliminating Zookeeper to organize all its operations within the brokers without the assistance of Zookeeper. I will show you how to run Kafka without Zookeeper. But I couldn't help but mention it, because anyone who wants to work with Kafka will encounter Zookeeper. You can work with it, or you can work without it. There are 2 options. We will be working in Craft mode, so-called, in which Kafka operates without Zookeeper. All the work of load balancing and handling metadata falls on the broker, the Kafka broker. What does it consist of? It consists of topics. A topic is a subject or category of messages where producer messages are recorded, and from which consumers later read. Topics are usually named accordingly. First the noun, then the verb, and at the end, the topic. For example, order created or product updated topic. The topic name indicates what type of events are coming into this topic. Now let's take a look inside the topic and see what it consists of. A topic consists of partitions. A partition is a part of a topic. The number of partitions is also specified manually. They are needed for parallelizing the stream to ensure greater throughput. In Kafka, information can be written to any partition. For example, the first partition has 4 events recorded, the second has 3 events, and the third has 3. Kafka itself decides which partition to write to, the first, second, or third. Naturally, there can be more than just 3 partitions. There can be as many as we configure. A message, or message, is precisely the unit that goes into a partition. These numbers are called offsets. You can think of Kafka as just a regular log file where messages are written and accumulated. The offset 1234 represents a position within that file. When a consumer enters the topic, they can choose any partition. For example, it will first read the first partition, all the messages, first, second, third, fourth, then the second, first, second, third, and then the third. The second consumer can enter and start with the third partition, then the second, and then the first. This ensures parallelism in reading. However, within a single partition, all messages are read one after another in order. There can be a situation like this. Topic-product updated-topic. We updated a certain product. We updated a certain product. We updated a certain product. We had our product. This information was updated and sent to the map. Then we updated it again, sent it to the map once more. After that, we updated it a third time and sent it. So, we have 3 updates for this product. And these messages can end up in different partitions. For example, the first one goes here, the second one goes here, the third one goes here. Consumers may not necessarily read in the same order. They might read the last one first, then the second, and then the first. And in the end, the wrong version will be recorded. Well, the last one read, it kind of gets powered, and it will be incorrect. So, to ensure the correctness of message delivery to the consumer, there is something in the message called a key. Let's take a look at what a message consists of. When we send a message, we specify the topic in which we need to write the key and value. The value is, in fact, the event itself, the event value. A key can be specified or not specified. If it is not specified, Kafka will automatically determine which partition to write to. And if we assign the same key to these events that I mentioned earlier, they will definitely end up in the same partition and be recorded one after the other. And then the consumer processes them in the correct order. Headers are also an optional part. These are just key value pairs. Anyone can use them. The timestamp is automatically recorded, as well as the offset. We do not set the offset either. The offset is set by Kafka. What is an offset? I already mentioned it. It is simply the sequence number of a message in a partition, or the same as the offset in a file within the partition. Now let's install Kafka. Apache org Kafka download Kafka. We choose this one, Kafka 2.13.3.7.1. We download this in an archive 2.13.371. We simply unpack it. I unpacked it in the root of drive C. This is the folder that was created, Kafka 2.13.37.1. Let's go inside. I want to install Kafka with 3 brokers. For this, we go into the config, craft mode. Here we have 3 files, broker, controller, and server. So, the broker and the properties file is needed if we are going to configure Kafka with all servers only as brokers. The controller means we configure brokers as a controller. The controller is a server in Kafka that distributes tasks. It is responsible for more than just receiving messages. The broker is simply responsible for receiving messages and writing them. The controller is responsible for distributing tasks. Among the brokers, I forgot to mention an important thing. Messages are only written in the broker. They cannot be edited or deleted. They are only for writing and reading. The server properties file is needed for configuration if we want to set up our servers as both a broker and a controller simultaneously. So, I wanted to create 3 servers. To do this, I will copy this file 3 times and name them Server 1, Server 2, and Server 3. Now we need to change the settings of these files. So, the first thing we need to change in the server properties file is node ID. This is the parameter node ID. This is the parameter node ID. For the first server, we leave it as 1. For the second, we write 2, 4. Third, 3. Next, listeners. This is the second thing we need to change. Here, the ports on which the server will operate are specified. The first port 992 is for the broker's operation. 9093 is for the controller's operation. In the first file, we insert 92, 93. In the second, we do 94. This is 3 in the second, we do 94, 95, 95. Third, 96, 97. The next thing that we need to change in these files is the advertised listeners. This is the list of brokers that are also advertised to clients. Here is such a complex formulation. Here it is, advertised listeners. In this case, it simply repeats the broker's port because we have Kafka and the producer and consumer are on the same network. If they are not on the same network, then the external port is specified here. Next, controller, worm, waters. Here are the indicators. We need to specify. It's like voting listeners. In general, here we need to specify all the controllers, all 3 via IP. Here. The ports of the controllers are specified. I will copy this line to the other 2. So, the last one, logders. This is actually where the logs are written. So, log basic logders, logs, are recorded in TMP. I will write server 1. This is the third one. Server 3 means server 3. We save, we close. So, what should we run? In this directory, we navigate to the bin folder. If you have Mac OS or Linux, we run the scripts from the bin folder with the sh extension. If it's Windows, then from the Windows folder. Here are the same scripts, only with a bad extension. Let's go here, to the command line. First, we need to navigate to this folder. We copy the path. The first thing we need is to obtain the ID for the Kafka cluster. This is done with the following command. Here it is. Next, we need to format the logs for each server for the craft mode, because by default they are formatted to work with Zookeeper. I will write this command. An error just popped up because I already have a Kafka cluster created. I was just writing here. It was already created under a different UID. If you are doing this for the first time, you won't encounter such an error. I will just redo it now. It says that it is already formatted. In general, everything needs to be done 3 times for each server. First, servers 1, then servers 2. Server 3. So now you can start it. For this, the command pip kafka server start bat is used. Here, we can see it. This is the command that needs to be written. I won't start them right away. I want to open 2 more windows for 2 more servers. They need to be started more or less simultaneously because they must see each other. As long as they don't see each other, these errors can occur. That's all for now. This one is running, this one is running, and this one is running too. Next, we can create topics, get their list, and work with the topics.